Assalamualaikum and hello to everyone. Today, we will present about vector and scalar. We want to express our gratitude to our lecturer Puan Intan Farah Dina Binti Zaine for allowing us to be here today. Allow me to introduce myself and my group members. My group members is me, Shabil, Chloe, and Camelia. What is vector and scalar? We come into contact with many physical quantity in the natural world on daily basis. For example, things like time, mass, weight, force, and electric charge are physical quantities. Objects have mass. Things have weight due to gravity. We exert force when we open door, walk along the street, and kick balls. We experience electric charge directly through static shock in winter and through using anything which runs on electricity. There are many physical quantity in nature, and we can divide them up into two broad groups called vector and okay, now I will give to Wei to continue our presentation for today. Please continue, Tay.
So, what is vector and scalar? Scalar are physical quantities which only have a number value or size, which is only have magnitude. A scalar tells us how much of something there is, while for vectors are different because they are physical quantities which have a size and a direction. A vector tells us how much of something there is and which direction it is in. In vector quantity has both magnitude and direction. Vector quantity can be 1, 2, or 3 dimension. Any change in vector quantity can reflect either change in direction, or change in magnitude, or change in both. The result of mathematical operations between two or more vectors may give either scalar, dot product, or vector product, summation, or subtraction. Example which is displacement, velocity, acceleration, force, and momentum.
Scalar quantity. Scalar quantity has magnitude but no direction. Every scalar quantity is one of the dimension. Any change in scalar quantity is the reflection of the change of magnitude. Any mathematical operation carried out among two or more scalar quantity will provide a scalar only. However, if a scalar is operated with a vector, then the result will be vector. Example: speed, length, area, volume, time, mass, density, and energy as the example of the scalar. Real-life application of vector and scalar. Vector have many real-life applications including situations involving force or velocity. For example, consider the force acting on a boat crossing a river. The boat's motor generates a force in one direction, and the current of the river generates a force in another direction. Both forces are vector. Scalar quantity are the measurements that specify refer to the magnitude of the medium. The motion of the aircraft can be described by vectors pertaining to displacement, direction, acceleration, and velocity. Example: speed, strength. The example of scalar magnitude they are present in everyday life. That's all from me today. Let's us pass it to Camilla.
Now, I will explain the basic formula for vector. The vector product of two vectors A and B is denoted by A times B. Its resultant vector is perpendicular to A and B. Vector products are also called cross product. Cross product of two vectors will give the resultant a vector and calculate using the right-hand rule. There are 5 properties of vector cross product. Next, Scalar product or dot product is a multiplication operation on vectors. The scalar product of two vectors is the sum of the product of the corresponding components of the vectors. In other words, the scalar product is equal to the product of the magnitude of two vectors and the cosine of the angle between them. It is a scalar quantity and is also called the dot product of vectors. There are 6 properties of scalar dot product. This is the example of mathematical solution for vector and scalar. So, the conclusion is, vectors and scalars are very important in our daily life. And we also know that vectors are used in wide scope in everything to represent quantities that have both magnitude and direction, even many quantities, such as force, displacement, velocity, acceleration, speed, volume, time, mass, and so on, present as vectors and scalar for analysis.